Good morning, Algebra 1 students, and welcome back to Topic 10, Non-Factorable Quadratics. Today's lesson is on 10.4, and we are going to focus on solutions to or of the quadratic formula. Before we jump into the quadratic formula, though, we're going to go ahead and look at this fraction that is given to us on the opener. That fraction is, of course, negative 5 minus 2 divided by 4. And we're going to address a common mistake that students will make throughout today and that we're going to try to cut off at the beginning so you don't make this mistake. So we unfortunately had a student that already made a mistake. Your goal is to identify the mistake, so to figure out what's wrong, and show the work to find the correct answer. And as a bonus, we're going to try to find the correct answer on our calculator by just pressing enter or equals one time. So let's start with the incorrect way to do this. Someone saw the negative 5 minus 2 divided by 4. So they said, okay, negative 5 minus 2 divided by 4. They put that into their calculator, they hit enter, and they got negative 5.5. Well, I'm telling you right now that's wrong, but what I'd like you to do is try to get the wrong answer. And it's very easy to do. Just type this into your calculator. And I have my calculator ready to go. I'm using an 84, but the keyboard is pretty similar to the TI 30X2S's that you guys use. If you don't have a calculator available, then you can use the Desmo Scientific one, though that one's going to make this almost too easy. So either way, let's see what we can do. First thing we want to make sure is that we type in a negative. So use the negative button for negative 5. And then I don't want to type in negative 2. Right, negative 5, negative 2 does not say negative 5 minus 2. We need to make sure we use that longer minus button. So minus 2, and then divided by 4, and we get negative 5.5. That is definitely wrong. So there are two questions we need to answer here. First, we need to understand what did we do wrong, and second, how do we get the right answer of negative 1.75? Now, what many of your classmates did here, and this was very clever, is they realized, well, I want to do negative 5 minus 2 first. So they did negative 5 minus 2, hit enter to get negative 7 for the top, and then hit divided by 4. And when they did that, they got the negative 1.75. And they are correct. But in this problem, I would like you to get the negative 1.75 by hitting enter only one time. And I had to hit enter or equals twice. I did it once for negative 7 and again for negative 1.75. So how do we do all this math at once and not get the wrong answer? Well, think about why they got the wrong answer here. What they ended up doing, if you think about PEMDAS, is they went through and they said, okay, PEMDAS, there's no parentheses, there's no exponents, there's no multiplication, there is division. Where's the division? Well, the division is right here. So they went through and did negative 2 divided by 4, which is negative 0.5. They did that first. And in the fraction, did you want to do this first? I don't think so. In the fraction, you'd like to do the numerator, the entire numerator first. So how do we force the calculator to do that correctly? I'll help you out. Negative 5 minus 2 divided by 4. We're going to type the same buttons, but more. And hopefully you're thinking, well, to force the calculator to do negative 5 minus 2 first, we just need to group that in parentheses. And you are correct. So negative 5 minus 2 divided by 4, we'll just do it in parentheses. Negative 5 minus 2, all of that divided by 4. So two things to keep in mind for today. If you don't remember parentheses, then you are welcome to do it in two steps. You can do the top first, hit enter, and then divide and hit enter. Many of my students, though, are trying to be efficient and they want to do it all at once, and they forget parentheses. So moral of the story, you need parentheses. However, a side moral of the story, if you have one of those nicer upgraded calculators that has a fraction button, you should use it. For example, there's one hidden on the 84 up here, like so. And so I should just be typing in negative 5 minus 2, all of this over 4, and hitting enter. Now I got a fraction here, and you need to be comfortable on your fraction converting that to a decimal. For this one, and again, this isn't the calculator you have, there is a decimal conversion here to decimal right down here. And so I get the negative 1.75. You should be comfortable converting between fractions and decimals on any calculator. All right, with that being said, let's go ahead and get into the algebra part of today. The algebra part of today is really these three problems at the bottom of the page. Okay, the zeros are given for each quadratic equation. Where do they give us the zeros? Oh, they're down at the bottom. Okay, and they want us to use the quadratic formula to show the work to match the answers. Okay, well, quadratic formula. I'll rewrite this one at the top of the paper. Nothing too bad. X equals negative b plus minus. Remember, we learned this in 10.3, so make sure you've watched that before jumping in here. 4ac all over 2a. So a quadratic formula solves any quadratic equation that's set equal to what? Oh, that's set equal to 0. So we should probably do that first, especially because they said they gave us the zeros. So my first step here, and we're definitely going to want to write somewhat small for these problems because there's quite a lot of room, especially when you involve the quadratic formula. Okay, so 0 equals x squared plus 4x plus 4. Good so far. I'll put in those invisible 1s in front of the x squareds, and that's going to let us identify a, right? Pretty easily. Okay. We need b. That's negative 4. Don't forget the signs there. B and b. And then, of course, we need c. All right. Now that we found a, b, and c, and I'm just doing all three of these at once, at least for the setup, let's use that quadratic formula. So go ahead and pause the video, do the quadratic formula for each of those values, each of those equations, and see if you can match the answers. If you get any of them, nice job. There are three different skills to get the answers here. If you don't get any of them, unpause and I'll give you some hints. Ready, set, go. All right, we're back. Let's quadratic formula this. X equals, and I'm just going to leave some blanks here. And that'll let me fill everything in. Let's see, minus 4ac. And of course, if you've already done this, you should be skipping through this part, right? Now, if you're not sure how to do it, you can watch me and do it with me, but hopefully after 10.3 you're pretty comfortable with this. As a reminder too, we do have other options to solve these equations. Sometimes you can use the box. In fact, on h of x, if you look at the answer at the bottom, because the answer is a nice integer number, I bet we could have just used the box here, no problem. But the focus is the quadratic formula, so we're going to play the game and try the quadratic formula. Okay, so something like this. All right, let's get these filled in. I'll do the a's first. So minus 4ac all over 2am, ac all over 2am, and ac all over 2am. Good. Then we'll do the b's. So notice there's already a negative, and I need to include another negative here, a negative negative. And so this one's not too bad. This one is also not too bad. So there's only one of those negative negative issues. Be very careful there. They'll try to trick you with that on the test. And then c is easy. It's just the number at the end here. Good. Okay. Once we're here, the next step is to start to simplify, just like last class. Now, the simplification we did last class had three parts. And two parts are pretty easy. First, we looked at that negative b out front. So negative negative 4 becomes positive 4. And at the same time, 2 times 1 is 2. Last but not least, we have to simplify the inside of the square root, but I'll come back to that in just a second. All over negative 4, and negative 4 plus minus some square root all over 2. Now, remember to find the inside of the square root. I encouraged you to take all of this. Let's use a color where we can still read what's inside. All of this, and substitute it into your calculator. So you should probably try that now. Negative 4 squared minus 4 times 1 times 1. However, if your mental math is good, I do encourage you to try the mental math as well. I can see that this is 16 minus 4, so this has got to be 12. This is going to be 9 plus, because of the two negatives. 8 times 6 is 48. 48 and 9 is going to give us 57. And then last but not least over here, 16 minus 16 will give us 0. So make sure you got those three using your calculator. You can pause to double check. You need to be able to get those numbers to have success for the rest of this problem. Now, we should also realize that we're not done yet, of course, because if you look down here, we have 3 answers and none of those match what we have. We have weird fractions. Okay, so let's actually start in reverse. Let's start with the last problem to get that -2, because I think this one's not too bad. We actually did one very similar to this last class, because we know the square root of 0. 0 is arguably a perfect square, and the square root of 0 is just 0. Since we know the square root, we can take the square root. We don't need to write the square root anymore, and now it's just over 2. Okay. Once we're here, we're going to go ahead and make 2 separate equations, where one equation is going to use the plus, and it gives me x is -4 plus 0 over 2, and my second equation is going to use the minus, and that's going to give us x equals -4 minus 0 over 2. From here, doesn't this look just like the opener? You could plug all this into your calculator, or you could do the math. The math, I think, is not too bad. -4 divided by 2, which is, of course, -2. And then on the other side, we do need to look at both of these. -4 minus 0 is -4 divided by 2, and so we again get -2. We should expect to be getting 2 answers here because this is a quadratic, and we learned that fundamental theorem of algebra. Whatever the largest power is in the problem, that's the number of solutions we should get. We got 2 solutions. Now, of course, you wouldn't write 2 separate solutions because they're the same. You'd just write one of them. But we should realize that that -2 actually has 2 -2's in it. All right, so there's our first problem done. Okay, we're just going to keep working backwards, I think. If you look at this second problem, we have decimals here. As soon as you see gross decimals, irrational decimals as your answer, we really want to start thinking about using our calculator. Because the square root of 57 is not a perfect square. I cannot name 2 numbers that multiply to get 57, right? 7 times 7 is 49. That's smaller than 57. 8 times 8 is 64. That's larger than 57. So because of that, I'm pretty confident the square root of 57 is between 7 and 8, 7 point something, but I don't know what. Now, again, the giveaway that we need to actually find the decimal equivalent of the square root of 57 is the answers. And you'll see this on the test too. If there's a problem like this, they will give you decimal answers, and so you'll know that you'll need to bring your calculator into play. So how do we do that? Well, we pull up that friendly old calculator, right? It looks something like this, and we're just going to take the square root, second x squared on most calculators, of 57. When I hit enter, 7.5498 blah 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 blah. So I'm going to write 7.549. 7.549, I can remember this, 7.549. So we have x equals -3 plus minus 7.549 all over -4. And see, I was right. The answer was somewhere in between 7 and 8. That's cool. Now, realistically, you should write as many decimals as you can, or even keep the square root of 57, and I'll show you how to do that in just a second. But for all intents and purposes, going at least 3 numbers past the decimal will be just fine. I think I've read that even when they're sending like rockets up into outer space, NASA only uses pi out to 6 decimal places, right? So once you go too far, it doesn't become any more accurate. All right, so now that we're here, what do we do? Well, this problem is actually very similar to the one that we did to the right. The right we had a 0, here we have a number with a decimal, but we could still, I think, make 2 different equations here. And so I'm going to do the same thing again. We're going to do one equation that uses the plus, so -3 plus 7.549 whatever over -4, and of course one equation that uses the minus. -3 minus 7.549 whatever over -4. And then it's calculator time. So we're going to go through, and I'm actually going to do all of this at once on my calculators to see what we get. Not only will that save me some space, but it will also be a little bit more accurate. And in fact, we're going to discuss a couple accuracies in just a second. So let's go ahead and pull up that calculator again. If you don't have one in front of you, get one. And I'll pretend like mine doesn't have a fraction button on here. So I'm going to do parentheses, negative 3 plus 7.549, all of this divided by negative 4. If I do it correctly, negative 1.137. Hey, look, there's one of our answers. So we're going to go ahead and throw that one on here. So we have negative 1.137, and that looks pretty good. Now, a couple things to note. First, is that perfectly accurate? Well, no, it's not accurate. I could have gone more decimal places, but more importantly, 7.549 isn't actually accurate, right? Because the square root of 57 is irrational. There's an infinite number of decimals past it, never repeating eventually into a recognizable pattern. So actually, I'm going to copy this down, and all calculators can go back and copy something they've done before. And I'm going to go ahead and type in my square root of 57 instead of the decimal. In fact, that's probably what you should do on a test. Instead of writing a decimal here, why not use the most accurate version, the square root of 57? And if I hit enter, notice that it's negative 1.137, so it matches for the first three, but then once we get to the fourth, now it's a 4 instead of a 2. And so we're actually 2 10,000ths off, just 4 decimal places out. Now, it's still accurate to the first three, and that's fine for us. But again, realistically, if you're doing these calculations to get a decimal, you should probably use the square root of 57, the actual right decimal, instead of a rounded decimal part of the way through. And so I'm going to go ahead and copy the less accurate one and change this to a minus so I can do the green one pretty quickly. Save me from having to slowly retype. 2.637, that matches, that's good. I wonder how close that is if I use the actual square root of 57. Now, of course, the calculator doesn't have the actual square root of 57 either. It just has it stored out further than 3 decimal places. 2.637, and again, once we get to that fourth one, it's that 2 10,000ths off. Okay, so it's 2.637, and we're set here. So again, we knew to use decimals because we looked at the answer. The answer had decimals, so we turned our square root into a decimal. Let's go ahead then and take a look at our first one. Our first problem, you might be tempted to think, well, let's see, does the square root of 12 have a nice answer? Well, 3 times 3 is 9. 4 times 4 is 16. We skipped right over 12. The square root of 12 is somewhere between 3 and 4. Okay, so not a nice answer. So do we use our calculator to find decimals here? Well, if you look down at the answer, does the answer have decimals? It does not. What the answer does have, though, is a smaller number. This is the radicand, a smaller number inside the square root. So if we look back up here, we have to ask ourselves, how did they make the 12 smaller? And in fact, the only way we know how to do that isn't through this division here. This number outside of a square root cannot combine with a number inside of a square root. So it's not division. In fact, the only way we know how to do this is with our breaking down the square root of 12. Do you remember that? Square root of 12, and then we break it down. You can break it down anyway. I'm thinking 4 times 3, and then 2 times 2. Okay. Now, the other way, of course, to break down the square root of 12, the way that I prefer, is we can again use 4 and 3, but I would keep them inside the square root, and then think, do we know the square root of either of these? And we do. We know the square root of 4. The square root of 4 is just plain old 2. I don't know the square root of 3, so it's 3. The other way you can do that is say, here's a pair, stays on the outside. Here's a loner, goes on the inside. Okay. So either way, square root of 12, this guy right here, is the same as 2 square roots of 3, which means in this problem, I can say x equals 4 plus minus, no longer the square root of 12, now 2 square roots of 3 over 2. Once we're here, there's a couple different ways to come up with the answer. And I'm going to give you 2 different options right now. Now I'm going to split this in half. Normally you would just do one option, but here's the 2 different ones. Option 1 is we can remember that if you're dividing, you can distribute division to all the different terms, and terms are separated by addition and subtraction. So if I wanted to distribute the dividing by 2, I would get 4 divided by 2 plus minus 2 root 3 divided by 2. And then we can just do the division. 4 divided by 2 is 2. 2 over 2, right, cancels and just leaves me with the square root of 3. And that's our answer. However, the other way that we can do this, and this will become important later on this class, I think, is when we end up with this, we can realize that this is a fraction, and you are allowed to multiply or divide a fraction by any number that you would like. And looking at 4, 2, and 2, I think the greatest common factor of all of these is a 2. And so I'm going to go ahead and divide everything here by a 2. This will give me then 2 plus minus 1 square root of 3 over 1. And don't forget our invisible ones, right? If you're dividing by 1, we really don't need to write that. And if you have 1 times the square root of 3, you don't need to write that. And we end up with 2 square roots of 3. So again, 2 ways to do this problem. Both of them will get you to the answer. Make sure you understand both methods. Okay, well that is really our main point for today. We have one more page to go through, but this page goes pretty quickly. So let's get to it. Quadratic equations make a graph called a parabola. We know that. That's our U-shaped graph. All graphs have zeros. Seriously, they all do, even if they don't touch the x-axis. And don't forget that a 0 is a fancy way to say an x-intercept. This means then that parabolas can have the following number of zeros. Well, we could have a parabola that looks something like this, or it could be going downwards, and this certainly has 2 zeros, right? We can see we cross the x-axis once and twice. Not bad. However, we could also have a parabola with only 1 0. Can you envision what that looks like? I can only touch the x-axis once. Well, what if it looked like this? Doesn't that only touch the x-axis one time? And we can also have a parabola with no zeros, or with 0 zeros. And I'm going to try to change colors again. 0 zeros. And for 0 zeros, what if you had a parabola that was just floating above the x-axis? There are no x-intercepts here. Now, why are we going over this? Well, last class we discussed a part of the quadratic formula, b squared minus 4ac. And we said that that part of the quadratic formula was known as the discriminant. We used it last class to decide if our quadratic would have integer, nice numbers, so we could use the box, or irrational, not nice numbers. However, it also tells us one other thing. The discriminant also tells us if our parabola has no x-intercepts, 1 x-intercept, or 2 x-intercepts. How? Well, let's think back to the previous page. When I used the quadratic formula, I got one answer here. Can you see why I got one answer? Right? Normally, a square root has plus minus in front of it. And when you do the square root of a number, that plus minus gives us 2 answers. But in this case, when I did the square root of a number, the plus minus only gave us 1 answer, because negative 0 and positive 0 are the same number. So, it turns out that a quadratic will always have 1 0 if the b squared minus 4ac part equals 0, right? And that's because, if you wanted an example here, plus minus the square root of 0 is just 0. There's only one solution. One solution. All right. Well, that logic should make 2 zeros make a bunch of sense. 2 zeros, I'll give you the example first, right? If we had something like plus minus the square root of 16, the square root of 16 is both 4 but also negative 4. There are 2 solutions. So what caused the square root to have 2 solutions? Well, that would be if the inside was greater than 0, right? We even saw that with the square root of 57. It wasn't a perfect square, but the square root of 57 had 2 answers, 1 positive, 1 negative. All right, so then what would cause, or what would our discriminant be if there were no solutions? Well, I guess the question you have to ask yourself then is, if you were thinking about a specific example, the square root of what would be no solution. And hopefully you're thinking, oh right, that's that negative number thing. Yeah, if you try the square root of negative 4, you'll get no solution on your calculator because we can't do square roots of negatives, at least this year. So if b squared minus 4ac is less than 0, then you know that there will be no solution. All right, let's finish off class today with one graphing problem. We want to make sure we can put everything together and circle back to graphing. That's going to be a main focus for the next couple days. We're going to graph the equation g of x equals negative 2x squared plus 3x plus 6 by finding each piece down below. Okay. Well, the first one we're going to find is the zeros, and we know by now to find the zeros we set 0 equal to our equation. But this step might give you a little bit of a pause, because in order to solve this, we know there are several ways. The first way is by using a box, but I have set this up intentionally, and this is in non-factorable quadratics, such that the box won't work. So then the second step is completing the square. Second option is completing the square, but there isn't a 1 in front of x squared, so that's out. So then our third and final option is the quadratic formula. But I did not leave you a lot of space here to do the quadratic formula. Luckily, I gave you a hint though, huh? We saw this on the previous page. Where? Negative 2x squared plus 3x plus 6. Let's take a look. Oh, here it is. It's g of x. It's the one right in the middle. And look, we already used the quadratic formula to find this. We got two answers, negative 1.137 and 2.637. Well, that was convenient. It's like it's all part of the plan. Negative 1.137, comma 0, and 2.637, comma 0. Well, that's nice. Now we know our x-intercepts. Now, the nice part with graphing is we don't have to be perfect, right? Negative 1.1, here's negative 1, here's negative 2. Negative 1.1 is on its way to negative 2, but not quite there, so just somewhere around here. And 2.637, well, 2.5 is kind of right in the middle, so 2.6 has to be just a little bit more over, something like that. Two x-intercepts. All right, let's go ahead and find the vertex. We know the vertex is exactly in between the two x-intercepts, but I think counting what's exactly in between might not be super accurate. So let's find the other way to find the h value, and that is by finding the average or the mean of the two. We take negative 1.137, we add it to 2.637, and then divide by 2. So why don't you get those calculators rolling? I'll do the same thing over here. So we have parentheses, negative 1.137 plus 2.637, and it is all divided by 2. Oh look, we got a nice number, which is actually pretty fascinating, right? The fact that we took two irrational decimals that go forever and don't have a nice fraction form, and found that when we added them together and divided by 2, the irrational parts canceled and gave us exactly 0.75. Yeah, I think that's pretty cool. So 0.75. And if you look visually, right, in between these two, I think 0.75, which is right about there, is a pretty good approximation of being exactly in between. So I know I have to go over to 0.75. In fact, that's my axis of symmetry right here. Okay, but I don't know how far up or down the axis of symmetry. So we need our k value. K value, of course, is found by substituting 0.75 in for all of our x's. So negative 2 by 0.75 squared, plus 3 by 0.75, plus 6, and I'll do the same thing. Negative 2, 3, and 6, I think I can remember that. Negative 2 by 0.75 squared, okay, plus 3 by 0.75 plus 6. And I get 7.125. 7.125, hopefully I can remember that as well. This, let's see, g of 0.75 is 7.125. There we go. And now we can get this graphed. 0.75, comma 7.125 is somewhere just above 7. Nice. And now I have my 2, oh, haha, 0.75, that's awkward. I was like, that's not exactly in the middle. 0.75 is over here. There we go. 7.125 looks like this. There we go. That's much better. And now we have 3 points, but we are always looking for 5. So let's find the y-intercept. Our y-intercept is usually a pretty easy setup. just involves replacing the x's with 0. So negative 2 by 0 squared plus 3 by 0 plus 6. And hopefully you'll realize that by multiplying by 0, we cancel out all of these. And it just leaves us with 0 as the input, 6 as the output. 0, 6. This is 0.75, so 0.75 away. Symmetry looks like this. And I think we have a pretty nice parabola now. Something like that. Put it all together, right? Second try, there we go. And we've got our nice downward, because of that negative, facing parabola. Let's finish this off with the domain and range. We know x is all real numbers. Our graph gets infinitely wide. We can use any x value. A couple ways to think about it. The range, well, the highest the graph gets is up here. So the highest it gets is 7.125. That's from our k value of our vertex. And then the graph goes below that. So below, we would say y is less than, and it can be equal. There is a point right at 7.125. Y is less than or equal to 7.125. Okay, so this really finishes off anything new for today. The last part of today is a solving quadratics practice sheet. So you've got a riddle here, and I'm going to go ahead and flip it over this way. What do you call it when somebody spends 20 years in the 24th row of a theater? It, of course, will be hilarious. So you can see that there are 14 questions here. And if you look at the answers, most of the answers have square roots in them. And so that means that most of these problems you'll need to use the quadratic formula for. However, there are a couple, 1, 2, 3, 4, 5, 6. There are 6 questions. So that's almost half. So there are 6 questions here that have nice numbers, which means some of these you can use the box on. Right? So if you're pretty good with your box method, maybe this first one, I'm not even sure, maybe you can find factors here, and I would just guess and check. You guys could probably use the box though. Let's see, 5, 1, I think if I do -1 and -5, it's -5, -6, yeah, that would work. So there's a quick factor form of this one. You can solve it pretty easily. But there are, of course, going to be many where you can't use that, and so you might just want to practice the quadratic formula for each of them. Also, last hint, don't forget that the quadratic formula needs to be equal to 0. I'm not trying to promote this page at all, but it did come from Pizzazz Algebra, and it's always important to cite your sources. So there we go. Good luck with this. If you have any questions, as always, let me know, and thank you for tuning in. Have a great day.